So this is a quick example of how to use corrosion Djinn to minimize galvanic corrosion. So the scenario might be the materials and process engineer has been asked what material should be chosen for bushings to be used in an aluminum aircraft structure. So for a maritime environment we choose 3.5% sodium chloride, and we're going to look at various galvanic couples between material 1 and material 2. We describe each material by the substrate, the designation, coating and a treatment. So a substrate is the alloy or the element. We'll choose aluminum. Designation could be the alloy type and heat treat. The coating will have no coating for the moment and no treatment. We'll come back to that in a moment. And we're considering stainless steel bushings. So we choose stainless steel, 15.5 pH, no coating, no treatment. Press save. It pulls the data, and what we can see is a summary table here where automatically the anodic material is chosen, which is the aluminum alloy, and then we have the cathodic material, which is the stainless steel. We have the self-corrosion rates of each one and the self-corrosion rate of stainless steel, which is quite low of course, and then the kicker is when you actually put these two together and you get this galvanic corrosion rate down here, which actually is a factor increase of between 6 and 7, as we show over here. So that's quite a high corrosion rate, but normally we would anodize the aluminum. So what we can do is choose a new group. So we'll copy, so that's group 2, and we modify it, and we'll just choose one of these elements that are being pre-populated. So boric sulfuric acid anodize with an anodized seal of chromate against the same stainless steel. We save, and now this time the galvanic corrosion rate has gone down to 85 microns a year. So now what we can actually do is, well, let's see the impact of changing the bushing material. So we will copy, modify, and this time we'll change it to titanium Ti64. Save, and even though titanium is more electropositive, the actual corrosion rate, the galvanic corrosion rate, is much lower here at 1.55 microns a year.